Hello, I welcome you all to this wonderful lesson. And in this lesson, I've got this important question that I want to discuss with you. The question is falling under allotropes of carbon. So this question is falling under allotropes of carbon. Before we go any further, if you are new to this platform, don't forget to follow me. Don't forget to subscribe to this channel or page. So now, I'm from telling you that this particular question is falling under allotropes of what? Of carbon. So this is what we are talking about, allotropes of carbon. So these two that you are able to see here, these are two allotropes of carbon. Hope you are able to see this, you are able to understand clearly. The question is saying the following diagram shows two forms of carbon, P and Q. So the P and the Q, these are the two forms of carbon. So name the allotropes labeled P and Q. How can you name the allotropes labeled P and Q? So the P here that you are able to see, this one here is called the diamond. How did I know that this is the diamond? So the P here is the diamond. How did I know that this is the diamond? The same way it is like this. Have you seen these shapes? So before you go any further, you need to know that carbon has got only two allotropes. Mainly, there are only two allotropes of carbon, which are diamond and what? Graphites. There are four, but mainly we just focus on these ones. So anything that will look like this, the shape that is just looking like this, any shape you are going to see in this form, this one is bonded to four other types of carbon. This is how it is bonded to four other types of what? Carbon. So this is a diamond. The same way it is looking like this is how you are supposed to understand it. We move now to this other one. Have you seen this one has got this shape here? What is the name of this shape? This is something like an hexagon. Have you seen having six faces like this? So this one is called a graphite. This is what you need to know. That one is called the what? The graphite. This one is bonded to three other types of carbon. This is what you need to know. We move on to this particular question. So I just want you to understand this. Even as I'm explaining this, you're able to get one or two things to the point that when a question comes in an exam, a question that is falling under these things, you will be able to answer that particular question. So we move on to the other question that is saying, explain the meaning of the term allotropes. So what does the word allotrope mean? So this is the meaning. Allotrope is one or more forms of chemical elements that exist in the same physical state. So whenever we are talking about an allotrope, we are just talking about one or more, so one or more forms of what? Chemical. So chemical element that exists. So that exists in the what? In the same physical state. That exists in the same physical state. This is what you need to know when we are talking about what? Allotropes. This is what you mean. We've got two types of allotropes of what? Carbon. We've got what and what? So allotropes of carbon, we've got the diamond, which we've discussed. We also have another one, which is the what? Which is this one here. These are the common allotropes of carbon that you need to understand and get. I'm not saying these are the only ones. These are the common ones. Get this. Then we move on to the other question. what type of bonding is represented by these forms of carbon? We know that these are non-metals. And for this to be called non-metals, which means that the type of bonding that gets to exist between them is what? Covalent bonding. It is covalent bonding. The other name for covalent bonding, we can call this as molecular bonding. You can call it as molecular bonding. So I want you to get this. So here the question is, the answer is covalent what? Bonding. This is the type of bonding that is shown in this. These are things that I want you people to know. These are things that I want you people to understand. If they come in an exam, you must be able to answer them. We move on to the other question. This question is saying, which allotrope named in A has a physical property which is typical of what? Metals. So metals, we know that metals are made up of what? Metals are made up of delocalized electrons. Metals are made up of delocalized electrons, meaning that electrons that are free to move, electrons that get to move freely. Hence, they are moving, which means that they conduct electricity. So amongst these two, the one that has got a property of conducting electricity is a graphite. So graphites conduct electricity because they are made up of delocalized electrons. When I say delocalized, meaning free to move, able to move. But these ones, diamonds, this is the hardest material that we have on earth. So if you didn't know, you've known today on how to answer these particular questions. So the way these are, you need to know the same way this shape is and the way this shape is, you need to know these things. So the question is saying, which one now amongst these two? This one, which is made up of delocalized. This one is made up of what? Localized. So this one is localized. Electrons are not free to move in a diamond. But this one gets to conduct what? Electricity. Electrons are delocalized. Here they are localized. Then we now move on to the last question. State the physical property. We want to state a physical property. Physical property, I've already talked about it. These ones, you know that the answer here, these are graphites, which is Q on this one. So property of this same one, what is the property of graphites? These ones are soft materials. These ones, they conduct electricity. They've got high melting and boiling point. You can put any of those properties. So this is the question that I wanted to discuss together. This is the question that I wanted us to revise together. So those of you that want tuitions, if you want to start tuitions with me, this is the number that you need to text on WhatsApp. You can text me on this number. I'm your academic tutor. I do offer tuitions in mathematics, chemistry, and physics. So specifically for people that want to join tuitions, not questions, tuitions. So if you want tuitions, this is the number that you need to text on WhatsApp. It is only 100 kwacha per month, which is Zambian kwacha at the moment. Thank you so much. Don't forget to like the video. Don't forget to subscribe to this platform.